In this video, I'm going to attempt to be very bold, and this should be my last video, so I'm just going to go crazy and try to answer 3 questions in one video. And that's not just because it's the last video, it's because all 3 of these questions, numbers 13, 14, and 15, start off with take a look at figure 13-2. So I aim to draw roughly 13-2 and be done with it in my discussion right here, right now. That's what I'm looking to do anyway. Figure 13-2 is the one that we explained. It has the marginal cost and marginal benefit of air cleanliness, I believe is the, that's the horizontal axis label that he uses for our pollution or our clean environment. So let me go ahead and repeat what that model looks like. This is air cleanliness. I'm messing it up. That's air cleanliness down there. I'm not sure where it's going to cut off on the screen. Make it fit. And these are our dollar estimates of costs and benefits up here. 100% air cleanliness could be someplace like here. These are all in percentages. This, of course, would be 0%, totally trashing it. And then our marginal benefit is something like this. And our marginal cost is something like this. But we can go back on itself. It can't go that far. And so then we have our optimal cleanliness. This is the optimal amount. And this gap here would be the allowed pollution, the lack of cleanliness. And of course, then this would be corresponding to our optimal. I'm going to change my notation down here. This will be C star for cleanliness. And that would be our optimal marginal cost and marginal benefit for that optimal level of a clean environment. Now let's see what we're asked about it. Number 13, take a look at figure 31-2. Suppose that initially society were to opt for a degree of air cleanliness that is lower of Q naught. Okay, so this is what he's calling Q naught, that level. What would be true of the marginal benefit in relation to the marginal cost, and why would this fact induce society to increase the degree of air cleanliness toward that level right there? Well, if we were at an environment that was still dirtier, like here, if we were here, we could look at this situation, at least theoretically, and say, hey, the marginal benefit is greater than the marginal cost. If we clean up the environment, it will be better, because right now we can see it's better to do more than it costs us to do more. And we would move this direction. But let's say we're getting there just iteratively. Like we see, oh wow, it's better. We could do better without it costing us that much to do so, and we would move this way. But let's say we go too far. I think that's what the next one is. 13-4. Consider figure 31-2, I mean. So, suppose that initially society were to opt for a degree of air cleanliness that is higher than Q naught. What would be true of the marginal cost in relation to the marginal benefit? Why would this fact induce society to reduce the degree of air cleanliness toward Q naught? Well, if we had started off in this red amount and moved and said, oh, well, the marginal benefit's higher, let's make it cleaner. And we did that, and then we suddenly found ourselves in this situation where we're out here, and now we have a case where the cost of cleaning the environment, the marginal cost of cleaning the environment, is higher than the marginal benefit of it. We've done something where it's cost us more with that action than it's yielded us in benefit. And so we would back off of that. You see where this is going. It's sort of like we began the semester with exploring equilibrium supply and demand. 31-15, take a look at figure 31-2. Explain why 100% air cleanliness is not optimal. For this, I'm just going to read the textbook solution. At a 100% level of air cleanliness, the marginal cost of that level of air cleanliness normally will, as displayed in the figure, exceed the marginal benefit. Hence, the last unit of air cleanliness attained at 100% cleanliness level would generate a net cost to society for that unit. Society would gain from cutting back on air cleanliness instead of remaining at the 100% level. So we could get to a cleaner environment, but the cost of that movement would well exceed the benefit of that movement, because when you're up here at a near clean environment, it's already pretty clean, so the marginal benefit is pretty low. But to get a little bit more out of your effort, the marginal cost is very high. You're talking about, I don't know, maybe living outdoors or something like that, and that's a pretty high cost to bear to get the environment just a little bit cleaner to reach 100%. So hopefully that helps.